This, this is question number 6 of homework 5. You find a zero coupon bond with a par value of $10,000 and 20 years to maturity. The yield to maturity on this bond is 4.2%. Assume semi-annual compounding periods. So in this case, we have a semi-annual compounding for a zero coupon bond. So that means the coupon is zero, so only the future cash flows defer to only the par value. So what is the dollar price of the bond? The price of the bond is the present value of all future expected cash flows. And in this case, as we said, the only future cash flow for a zero coupon bond is the par value, and that's at the maturity date. So the present value of all future cash flows is simply the present value of all of the par value at the maturity date. But what's important here and what's easy to miss is that this is a semi-annual compounded bond, which means that we need to work with semi-annual terms for each variable. So that means the yield to maturity. In general, that also includes the coupon payment, but since this is a zero coupon bond, so we don't have to worry about that part. We only have to worry about the yield to the maturity. Yield to the maturity is 4.2%, so that's in annual terms. And so we need to get the semi-annual, which is simply this number divided by 2. Okay, so and par value is 10,000 and maturity is 20 years. So we need to, again, we need to work with semi-annual term for every variable. So that includes the maturity. So that means we need to convert this 20 years into the number of semi-annuals by multiplying it by 2. So that gives us 40. So now we can just use the I can just directly discount the par value back to the present to get the price, the present value. So I can just input like this, 1 plus, so it's par value divided by 1 plus the discount rate, semi-annual YTM, and raised to the power of the number of semi-annuals. So that's one way we can calculate this price. Another way is simply to use the PV function. So the first argument here is rate, and that refers to the discount rate. So that's the semi-annual YTM. And NPER is the number of compounding periods. So that's 40 here. And payment, that's the coupon payment. Since this is a zero coupon bond, so we enter 0. And future value, that's the par value. So we can directly input this par value as a positive number. And if we do that, the PV function will give us a negative value. So if we want to have a positive present value, what we can do is to make this to be a negative, the par value to be a negative number, but keep the absolute value. So, and you can see that these two numbers agree with each other, so you can copy either of them. So I copy this one back to the answer screen and check my work. Okay,